Is it audible now? Is it better?
Yes, ma'am.
No. So I was saying we were discussing the kinematics of circular motion, and here I had told you in order to remember the equations, you just have to do one task, that is to replace the variables. If you have linear displacement, replace it with angular displacement. If you have linear velocity, initial velocity, then replace it with initial angular velocity. For final velocity, we use final angular velocity. For acceleration, we use angular acceleration. So this is how our equations are constructed, and we had seen the derivation of all the three. I told you all to bring this, write the derivations too. The question also we had seen. Two questions only, I think we have done. Yeah, we had to. We have to start from torque. All right. So what is torque? Torque is basically the force in circular motion, in rotation. Whatever you know about force, force is a push or a pull, force is a quantity that produces change, or force is always in conjunction with displacement, whatever you have studied about force. Same thing about force, same definition about force, it's just that this is the rotational force. So instead of having, see, in every sector, we are having certain quantities which are representing them. Like we had the angular acceleration. Angular acceleration is doing what? Angular acceleration is representing all the types of accelerations. Correct. If it is representing all the types of accelerations which are present, so in our mind, we already have this thing fixed that we have angular acceleration, means we have acceleration in the rotation. We have acceleration. If we say acceleration, it means we have acceleration in translation. So when we are talking about these terms, there should be a concept clarity whenever we are saying something. If I say angular acceleration, it should immediately come to your mind that I am talking about rotational motion. I'm only talking about rotational motion. And when I'm just saying acceleration, linear acceleration, this means I'm talking about the translation. Fine class. So similarly, whatever force occurs, see, force is also a very important physical quantity which we had studied in laws of motion itself. So you already know that force is equally important in every aspect. So when we are talking about force and rotation, that becomes our torque. So instead of naming it as rotational force, rotational force, we have a direct term torque. Okay. So basically moment of force, it's written moment of force about the axis of rotation is torque. Now see, since we are talking about circular motion, certain things will be a little different. Okay, so that's why we have this axis of rotation. In rotation, we know the fact that we have an axis, and around that axis rotation occurs. So the moment of force about the axis of rotation is called as torque. So the way we have studied about the definition of angular momentum, in angular momentum, it linked between the linear momentum and the radius. When we were studying about the angular velocity, there was a relationship between linear velocity and the radius vector. Similarly, when we are talking about torque, here also there will be a relation between the linear force and the radius. Radius means the position vector. And force is the linear force. When I say force, it means I'm talking about the translational force. If I'm talking about the rotational force, I'll not be using the term force because we already have a name for it, that is torque. So it's the position vector. What is, okay, let's come to this. So tell me, this is clear, what is meant by torque? Just a second. My my video is also visible to you?
Yes, ma'am.
Yes, ma'am.
Okay, just a second. Give me a second. There's some issue from this side. Yeah, Zainab. See, Zainab, you know what is a force. A force is a push or a pull in simple layman terms. Okay. I've changed the connection. I've changed the Wi-Fi's connection. So if you still have any issue with the voice, anything, please tell me. I'll check it again. Okay, class. See, when we are talking about forces, there are forces that are acting in our simple translational part, linear part, straight line, right? But when we are talking about the forces which are acting in rotation, rotational motion is a separate subject. It's a separate topic. It's not simple linear motion. We know it's a separate topic. It's about rotation. There is a different velocity there, angular velocity. There's a different acceleration, angular acceleration. So similarly, you already know what is force. So force that is acting in rotational motion, we instead of calling it as angular force, we call it as torque. So it's not necessary that this would have been the name of torque. We could have it could have been named as rotational force, the way we have, or angular force, best angular force, like the way we have angular velocity, angular acceleration. But since it's a name which is provided to it, torque, that's why we are saying the term torque. The torque is basically force into radius. Force which is acting around the main axis and into radius, which is the separation to which it is acting. So force into radius, it is called as the torque. Now tell me, it's clear, or should I explain it again in another way or something? Class, clear or not?
Yes, ma'am.
Okay, yes. Let me just explain this one. See, first look at this. This is an axis, or forget this. I'll tell you here only. You have two cases here. You have two cases over here. Okay. One case is that there is a road. On this road, let's say a vehicle is moving. Okay. A vehicle is moving on this road. Or let's not write vehicle because vehicles have this engine. It will differ this. Let's say a box is kept on a table. Now I am pushing this box. Okay. I am pushing this box. So what will happen when I am pushing this box? As soon as I am pushing it, a force is being applied, right? A force is being applied. This force can be a push, and we know it can be a pull. Okay, this is one example. Now, one more example is, see, you have the fans like there is an axis in the center, there is a circular blade, and like this three, and this is attached to the ceiling. This is the case of fans. If there is any issue with the camera, also let me know. I think or I'll rejoin us. Okay, so this is the case of a fan. Now, when these blades are moving, this acts as an axis. This is the axis. This force was our translational force, linear force. Now the force which is acting around this axis to make the blades move. Why? Because these blades always move in a circular manner. Fan always moves in a circle, a complete circle. So this force which is acting in the rotation around this axis, this is called as torque. Tell me, class. Now it's clear?
Yes, ma'am.
Okay. Let's see. The derivation is very short. We don't even have a derivation as such for this. Okay. So see here what is happening. This is an axis where the torque is going to act. This is a point P chosen randomly. Now, when this point P is chosen, there is a force acting on it. Radius is there, and this angle has been taken as theta. For the derivation purpose, we have dropped this perpendicular OM because perpendiculars are very important in case of torque. So we have dropped this perpendicular. Okay. So this perpendicular is present. Why is this present? This perpendicular is present because of the derivation purpose only. No physical significance. Okay. So do not remember it as something else. Just for the derivation purpose. All right. Now see. Let's write this triangle. Okay. Yeah, let's look at this triangle. Triangle ONP. In triangle ONP. If I write what is sine theta, this is R1, which we have taken, R perpendicular, not one. So here this will be equal to, this is theta, so this will be equal to R perpendicular divided by R, right? So what is R perpendicular equal to? R sine theta. So again, I am saying this thing that why we have dropped this, it's for the derivation purpose only. Also one more thing, that this perpendicular is taken because we always take perpendicular from the axis. Only perpendicular from the axis is taken. All right, only take the perpendicular from the axis. So this is R perpendicular is equal to R sine theta. Fine. So this is the perpendicular which we have to take. So torque is equal to R cross F. That's it. R cross F. Cross product. So if this is cross product, you have to keep in mind that which theta will come, which angle will come.
Sine theta. Sine theta.
Yes, correct. It's correct. So this will be RF sine theta. So this is actually the placement of R. That's why we are writing it as RF sine theta. Just remember, this is the perpendicular radius. R is basically the perpendicular separation. R is the perpendicular separation from the axis. Perpendicular distance between axis of rotation and the line of action. This is what is the perpendicular distance, because this is only required whenever you are calculating torque. Okay, in torque, take perpendicular portion. See, when we are talking about torque's formula is R cross F. If we are talking about cross product's result is always a vector. So this is also a vector quantity whose SI unit, because it is force getting multiplied to the radius, so Newton meter. It's a very important topic. Torque is a very common topic. The way we talk about forces casually, normally, in every question, in every chapter, this is the significance of torque, because it's also a force only, and you know forces are very important. And when we are talking about the direction, you use right hand thumb. But here you don't need to apply. Basically, how do you use it? How do you use it when we are talking about the right hand thumb rule? You have the right hand, put your thumb along the direction of the axis and then curl it. Okay, curl the fingers. That will give you the direction. But do not remember it in class 11th, it's of no use. Okay, you don't have to actually use it in class 11th. Okay, yeah, this, what it is written, I'll tell you. See, if suppose this is the axis. Suppose this is the axis. This is one force acting F1, this is another force acting F2. Let's say this separation is R1 from this, okay? Now, when we are talking about the torque, so see, there can be two torques which are possible. One is due to this force, one is due to this force. See, when we are calculating due to the first one, it is R1 into F1 into sine theta. You know, theta here is 90 degrees. So torque here will be R1 into F1. But when we are calculating for the second one, look, torque is equal to R2 F2 sine 0 degree, right? Sine theta I'm writing here. And you know, here theta is equal to 0 degree. So torque will straight away be 0. This is how you calculate. It's just a small example. You will be asked to solve it. Okay, questions will be there. There will be lots of applications. First write it, then we'll start with angular momentum to start writing from here. Okay, class. So see, next topic is angular momentum. Now, what is angular momentum? Linear momentum in terms of rotation. The rotational linear momentum. Basically, rotational moment. Linear momentum is for the translational part, straight line part, and angular momentum is for the rotational momentum. So same thing when there is moment of linear momentum about an axis of rotation. So same thing, we represent it with a capital L. It is R cross P. Again, all these are vectors and all the vectors will lead to vectors. So this becomes RP sine theta. Okay, and R perpendicular is only R sine theta, because so you can even say this is R perpendicular into P. Yes, Alina, you tell what is the formula of linear momentum. Formula of linear momentum, Alina.
Ma'am, can you hear me?
Yeah, say.
Ma'am, the formula is
Mass, something related to mass into something. Try to recall.
MV.
MV. It's MV. Yes, Abir and Zainab. This should have been answered quickly because all your cameras are turned off, so we don't know how you all are answering this. Anyways, P is equal to MV. This is correct. And many a times I have told you when you enter the class, open the videos. So, yes, it's an axial vector. When we say axial vector, it means its direction is along the axis of rotation. If this, suppose this is the axis of rotation, so its direction will be along the axis of rotation. And same thing is for angular velocity. Same thing is for angular acceleration. Same thing, same logic is for torque also. So just remember, use mv. Now, one more formula. If P is equal to mv, then there should be a direct formula of this also. See, instead of mass, we write moment of inertia. That we'll be discussing in today's class. Moment of inertia, and what do we write for linear velocity? Angular velocity. So I omega is also a formula that we'll be using, and it's a very important formula. But one more formula is R cross. Okay, moment of inertia is starting. First, you write down this. Plus, see, the concept of moment of inertia, it's like mass. So whatever in the universe of motion in a straight line or kinematics you've studied and translational motion you've studied was mass. So in the case of this rotational components, you have it as moment of inertia. Okay, so moment of inertia is basically rotational analog of mass. So formula is very simple. Rotational motion, formula of moment of inertia is very easy. See, you take the mass, suppose this is mass 1 and this is the main axis and it is at a separation r. Or you take another mass, m2, it is at a separation r2 from an axis. Axis has to be there in rotation. Okay, axis has to be. So moment of inertia is represented by I. Okay, it is m mass into radius square. It's very important formula class and very easy too. Mr square, you can remember this. And what if there are multiple? Then m1 r1 square plus m2 r2 square plus m3 r3 square till nth are there. So mn r nth square. This is the formula you can use. What if the mass is variable? Then integral of dmr square you're going to use. Simple, very simple formula. Okay. One formula of ring which is commonly used. Calculate the moment of inertia of a ring about an axis perpendicular to the plane of a ring and passing through its center. You don't have to perform any derivation. This is a question. It's given in the form of a question. The answer you have to just remember it. It means this is the circle. Look at it. This means this is the circle. Okay. See, this is the plane. If you see, this is the plane which is in which plane? This is in XY plane. If I put it like this is how it is going to look like. YZ, not YZ. ZX, ZX, ZX. This is the axis. This is it. Clear? Like this. Okay. So this is the axis. This is the mass. This is the radius. Simply the formula for ring at when the axis is perpendicular and passing through its center, it is mr square. Not in any other case. There can be other cases also which are possible. Okay. Rod, this is a big derivation that we have to do. You write down this portion. Yes, when the mass is variable, that we'll see in this question only. Mass is variable, radius is variable. When you have to expand on things, then this we'll see in the rod question only. See, here you have to calculate the moment of inertia of a rod about an axis which is passing through its center and is perpendicular to its length. Through its center means somewhere here and perpendicular. So this is the axis. Means it will be rotating around it, around this axis. Okay. So if the total length was, let's say, total length was L. So this part will be L by 2 and this part will be L by 2. Mass here is M. Now we are going to do, since we do not have any information about this rod, what we are going to do, we are going to take a very small portion from this rod. Let the mass of this be dm, let the length of this be dx. This just this small portion, just this small part we are going to do. And you know, since if this is the axis, it means this is our origin, x equal to 0. So this will be x equal to plus L by 2 and this edge is going to be minus L by 2. I is equal to dm x square because it is, we have taken x. So dm x square, what the total length we have just taken, we are going to replace it. And we have to integrate it from one edge to the other edge. We have to expand it on both the sides. So it will be minus L by 2 to plus L by 2. See, class, look here. Mass of length capital L is capital M. So what will be the mass of unit length? It will be M divided by L. If you know for a unit length, then for this dx which we have chosen, we can calculate. So mass of, what is mass of dx? Mass of dx is dm, which we had chosen, but we didn't know the value. So now we can find out it is ml into dx. Now, since we know what is dm, let's put it here. Did you understand here? Mass of length L rod, when the length of the rod is L, then the mass is M. If what's the mass if the unit length is present? Mass of unit length, it's M by L, unitary method. If you know mass of a unit, then you can calculate mass for any length, right? If I say for 1 meter, the mass is M. So for 2 meters, the mass will be 2m. For 3 meters, the mass will be 3m. Yes, so if the mass for unit length is m by L, what is the mass of dx? Mass of dx is ml into dx. But the mass of the dx is dm. It means we have found the value of this dm. So when we put it, moment of inertia will be, this is a derivation only class. It's not a numerical. We are doing it in the form of a numerical, but it's a proper derivation that comes to find out for the rod. And anywhere it can come, this is the method you have to remember. Dx x square from minus L by 2 to plus L by 2. So I is equal to M by L. This is x square dx minus L by 2 to plus L by 2. Now class, x square when it is integrated, this is going to be M by L is already a constant. It is going to be x cube by 3 from minus L by 2 to plus L by 2. Let's substitute the value. I hope you know how it is done. X to the power 2 was there. So plus 1 divided by 2 plus 1. That gave us x cube by 3 in integration. So let's put the values. I is equal to, let's put the upper limit first, plus L by 2 will be put first. So I is equal to M by L into L by 2 whole, or 3 also. Let's bring this 3 also actually. So L by 2 whole cube minus L by 2 whole cube. This is M by 3L. This is L cube by 8. Minus will be plus. This is L cubed by 8. Same thing. So this becomes M into 3L divided by 3L. This is 2 into L cubed by 8. See, 1L will cancel this cube, it will become square. 2 here, 4 here. Final answer is ML square by 12. So when it is ML square by 12, it is ML square by 12. Yes, I'll repeat it. See, this is ML square by 12 when the axis is here. If we change the axis, there will be some other. Okay, I'm repeating it. All of you pay attention, and wherever you are having doubts in this question, ask and clarify. Okay, stop it right there. Okay. See, this is a rod. The question says that this is a rod given, and we have to find out the moment of inertia when this axis is given. Means perpendicular to its plane and parallel. Axis could have been different also. If this is the rod, this could also have been the axis. This could have been the axis on one edge. This question comes also where the answer is ML square by 3. When the axis is at this one edge, only one side. Okay, but now we have the formula right now. We have the question to find out the moment of inertia in the center. So I've told you, whenever you have variable mass, like here we do not know what is this mass. We have chosen a very small quantity whose length is dx and whose mass is dm. So I is equal to dm into x squared, right? Because the formula is this. This is just the formula. And we are extending it to from minus L by 2 to plus L by 2. Why we have done this minus plus thing? Because this is our axis. Axis acts as the origin. So x equal to 0 here. If it was at one edge, then this would have been straight away L. But since it is in the middle, it is passing through its center. This became L by 2. This side also became L by 2. And since this is on one side of the axis, so it is plus L by 2. And this is on the opposite side of axis, so this is minus L by 2. So I is equal to integral dmx square from minus L by 2 to plus L by 2. Now dm is unknown. How to solve this question further until you know what is dm. Dm into x square cannot be solved. You cannot solve it here because x either is this has to be dx x square or this has to be dm into m square. But since both of these things are physically different, they have physical dimensions different. This is mass, this is position. So we have to find out what is dm. What is dm, class? Dm is the mass of dx. Dm is the mass of length dx. So how can we find this mass? We have to find out the unit mass first. So mass of length L means complete rod is capital M. Mass of this entire rod is M. What is the unit length? Unit length means 1 meter. What is the mass of a unit length? It is M by L. If we say mass of, let's just take this example. Mass of 2 meter is equal to 10 kgs. Mass of 2 meters, length is 2 meters. Suppose the mass of a rod whose length is 2 meters is 10 kg. Then what is the mass of a unit length? What is the mass of 1 meter rod? If the mass of 2 meter rod is 10 kg, mass of 1 meter rod will be 10 divided by 2, 5 kgs. So that's what we are studying. Mass of length L is M. So mass of unit length will be M by L. Now, if you know unit length, you can find out the mass for any length. If I say for 1 meter, it is 5 kg. Now find out for 4 meters. Okay, for 1 unit, it is 5 kg. So for 4 units, it will be 20 kgs. You just have to multiply it with 4. It will be 4 times. For 1, if it is something. For second, it will be twice. For 3, it will be thrice. 4, it's like nth. You are multiplying it. So mass of dx will be m by L into dx length. Length is dx. We have just chosen a small portion whose mass is dm, whose length is dx. And this is infinitesimally very small. So once you know dm's value, we have got the value of dm, we have put it in the formula. Then we have integrated it. See, m by l is a constant, it will come out. X squared integral will be x cubed by 3. Lower limit minus l by 2. Upper limit plus l by 2. So when you are putting the upper limit minus lower limit, this becomes plus. This is L cube by 8. This is also L cube by 8. Same thing. So how have we solved the last step? We have solved the last step as this is m by L, m by 3L. See, if I say L cube by 8, or I say, if I say L cube by 8 plus L cube by 8, or I say 2 into L cube by 8, both are the same thing. Right? If I say 4 plus 4 is 8, or I say 2 into 4 is 8, that's the same thing. So that's what I've written. 2 into L cube by 8. Or what you can do, you can add this also and directly write 4 here. So this becomes L cube gets cancelled and here it is ml squared by 12. Tell me, all of you, is this question clear to each one of you?
Yes.
Ma'am.
Yes, ma'am.
Ali, is it clear?
Yes, ma'am.
Okay. Write down, all of you. Mark this as important. This is very important class.
Done, ma'am. Ma'am, can you scroll up a bit?